I'm Anil Kumar. Welcome to this particular video on quadratic functions. Let me thank my student for sharing his test paper. And I hope the solution of this test paper will help you to understand quadratic functions better. There are 11 questions here which we are going to discuss one by one. I will provide you with alternate solutions so that even if you are in different part of the world and you have learned different strategies to solve, the methods which I will cover will help you understand the concept. So let us first understand all these questions. Question number 1. Solve x square minus 8x equals to minus 12 by graphing. Question 2. Solve x square minus 8x equals to 9 by factoring. Question 3. Solve 3x square minus 2x equals to 2 using quadratic formula. Question 4. Solve x square minus 6x plus 9 by graphing. Question 5. Solve minus 0.5x square minus 3x minus 1 by completing squares. Question 6. Solve 6x square plus 24x minus 3 by partial factoring. So you have seen that we will be covering 4 different methods to solve quadratic equation. One is by graphing, the other one by factoring. Then we have quadratic formula, completing squares, and also partial factoring. So 5 different methods, right? Question number 7. Determine equation of parabola with roots at minus 2 and 6 passing through the point 1, 4. Find equation of parabola with roots at minus 1 and minus 7 with y-intercept of minus 9. So in question number 7 and 8, we will understand how to find quadratic equation given its roots. Question number 9. Find equation of parabola through 2 minus 18 and roots at 3 plus minus square root 7. Now this is a special case. We have a radical root here. So you need to be good at working with radical numbers. Question number 10. Determine number of intersections of the following linear quadratic system. So we are given 3 different systems. And as you know, b square minus 4ac, the discriminant, is to be analyzed to figure out whether we have 1 solution, 2 solution, or 3 solutions, right? So when we say determine number of intersections, we don't really have to find the solution. We only find the number of solutions. Perfect? Okay, so 3 different systems are given which we will look into. And then we have question number 11. Given linear quadratic system f of x equals to kx square plus 4x minus 3 and gx equals to 2x minus 7, determine the value of k for 1 solution, no solution, 2 solutions, right? So these are the questions which we will now solve one by one. This video might be about an hour long. So let's begin with the very first one, which is solve x square minus 8x equals to minus 12. Now minus 12 by graphing, that means we expect a integer value as a solution. 6 times 2, 4 times 3, and 12 times 1 are the numbers which should be of our interest, right? So what we could do here is we could actually sketch 2 different functions, treat this as a combination of a quadratic and a constant function, right? So we can have a graph of x square minus 8x. So we'll graph x square minus 8x on one side, and on the other side we'll draw the straight line which is minus 12, right? So with the help of these 2 graphs and their point of intersection, we could get the solution, right? Okay. So to graph this function, let's see it this way. We could also think about writing this in the factored form. You could think about taking factor of x, and then you can say this is x minus 8. Is that clear to you, right? So that gives you an idea of the solution also product of two numbers should be minus 12, right? So if you're thinking about 6 and 2, right? So if I write 2 here, then we get minus 6. So it does give you a solution, correct? So that is kind of a hint for you to do, right? Okay. So anyway, we are going to plot this particular part. So let's call this as the function f of x, right? So we are saying f of x is equal to x squared minus 8x. So I have substitute different values of x to calculate this, right? So if I write x equals to 0, for example, these are x values. Substituting 0, we get 0, right? If I write 1, then what do I get? So 1 times minus 7, right? So we get minus 7. If I write 2, so we get 2 times minus 6, which is minus 12. And if I write 3, we get 3 times minus 5. 3 times minus 5 is minus 15. If I write 4, we get 4 times minus 4 as minus 16. If I write 5, then we get 5 times minus 3, which is minus 15. 6 will give us minus 12, right? 6 times minus 2 gives us minus 12. So we need to have set of values to plot the graph. So if I write 7, so 7 times minus 1 will be minus 7, right? So clearly from this set of values, we do see a solution in our graph that the values 2 and 6 will give us minus 12, which we need. Is that clear to you? Right? So basically, if I graph this function, now let me sketch this graph here. So we are now sketching the graph of the function x squared minus 8x. So this particular parabola, right? So we could have taken a value which is, let us say, minus 1. Right? So if I write minus 1 here, I get minus 1 minus 8 is minus 9. So at minus 1, we get the value as plus 9. Correct? So you can see that the graph of this parabola will be kind of like this. So at 0 it is 0, right? So we'll just go, we are making an approximate diagram here with all these points, and we do understand that it is minus 12 at 2 points which are 2 and 6. So if I draw a line here, this is y equals to minus 12. Then we do have a solution, and the solution here is these 2 points, correct? And on a graph paper, you will find that these 2 points will be at 2 and 6, right? So 2 and 6 is our solution, correct? So solve by graphing, so we can say show these 2 points as our solution, and this is, the solution is 2 minus 12, and it is 6 minus 12, right? So we can write down our answer is x equals to 2 and x equals to 6 as our solution, correct? Now I will treat this as our method 1, right? This will be our method 1 to solve. I want to share with you another method of graphing and then solving the same equation. So we could actually rewrite this. So let me write down alternate method. Or you can say method 2. Is it clear? So we are given the equation x squared minus 8x equals to minus 12. We could bring all the terms together and we get the function, and then we say 8x plus 12 equals to 0. So what we will do here is graph the function f of x equals to x squared minus 8x plus 12. correct? So we will actually graph this particular function, and the solution will be when f of x is 0, right? So this particular, if you really factor, then 6 times 2 is 12. So you'll get kind of like this, right? So why I'm showing this work is that normally we'll actually sketch the graph like this. Correct? So this graph opens upwards since x squared, and it has two zeros. 0 is at 2 and 6, and the y-intercept is at 12. So the graph will be kind of like this. So in this case, this point is 12. These 2 points, the zeros are the solutions which are at 2 and 6. So you could actually rearrange and then x-intercepts become solution. So that could be alternate method of doing it, right? So both are right methods. Now let's look into question number 2. Solve x squared minus 8x equals to 9 by factoring. So we can write this equation x squared minus 8x equals to 9 as x squared minus 8x minus 9 equals to 0. Now we have a trinomial which we need to factor. So we are looking for two numbers whose product is minus 9 and sum of those two numbers is minus 8. So the numbers could be 9 and 1, right? So we could take one number as the bigger number has to be negative, right? So minus 9 and 1 can give you product of minus 9 and sum of minus 8. So we could factor this as x minus 9 times x plus 1, right? So these two numbers equals to 0. That really means that x minus 9 equals to 0. That gives you x equals to 9 as your answer. Or you could also do x plus 1 equals to 0. X equals to minus 1 is your answer, right? So we get two solutions. One is x equals to 9. The other one is x equals to minus 1. So that is how you could actually solve this particular equation. Question number 3. Solve 3x squared minus 2x equals to 2 using quadratic formula. So let's write down the quadratic formula. If the equation is ax squared plus bx plus c equals to 0, then x equals to minus b plus minus square root of b squared minus 4ac divided by 2a. That is the quadratic formula, right? So let's rearrange this equation. We have 3x squared minus 2x equals to 2. Bring 2 to the left side. So we get 3x squared minus 2x minus 2 equals to 0. Now in this equation, a equals to 3, b equals to minus 2, and c is equals to minus 2. So the value of x using this quadratic formula will be minus of minus 2 plus minus square root of b squared minus 4 times a is 3 times minus 2 divided by 2 times 3. So that gives you 4 plus minus square root of 4. Minus minus becomes positive. 4 times 3, 12 and 2, 24. Right? So divided by 6. Now this can be written as 4 plus minus square root of 28 over 6. Now 28 is 7 times 4, right? So we can write this as square root of 7 times 4, which is 28. Now 4 is a perfect square, so I could write this as 4 plus minus 2 square root of 7 over 6, right? Dividing by 2, we get 2 plus minus square root of 7 over 3 as our answer, right? So using quadratic formula, our answer here is we get two solutions. One is 2 plus square root of 7 over 3. The other one is 2 minus square root of 7 over 3. Clear? Question number 4. We have to solve this by graphing, right? So we have the equation which is x squared minus 6x plus 9. To graph, we need to have some values, right? So let's make a table of values. So that is a must. So once we have a table of values, we'll plot those values on a graph paper. Now I'm going to use rough sketches. You should actually plot it on a graph paper. So let's begin with simple values. We can always write down, for example, 0 gives me 9, right? Now if I write 1 here, what do I get? I'll use a calculator and I'll show you how easy it is to calculate multiple values. So the function here is x squared minus 6x plus 9. So we'll write here 1, it's good to use brackets, right? So when we are writing general function, so we'll write within brackets 1 square minus 6 times within bracket again 1. I'm substituting 1 for x, right? Plus 9. And that gives me a value which is 4. Now, I'll replace 1 by 2, right? So I'll replace 1 by 2 and then again calculate. Now the answer here is 1 and then we'll do 3. I'm again going to replace now this time 2 by 3, right? Now since this formula is there, we just change the x values and keep on repeating the process, correct? So now we'll do 4. So it becomes simpler and it is far more accurate. It takes lesser time also. So we get now the value 1. As you see, they repeat. So we know we got a vertex here. And when we do 5, we expect what? Can you tell me? Looking into the symmetry, we do expect this value 4, and at 6 we'll get 9, correct? Well, likewise, these are good enough values. So we see that we got all these positive values, minimum being 0. This is a parabola which opens upwards. So if I'm going to sketch this particular parabola, what do I expect? So the graph of this parabola should be like with one vertex, right? So y-intercept of 3. So let me just sketch a parabola first. So somehow it should be like this, right? Where the solution, so that value, y-intercept will be 9, and this value, where we have a turning point, minimum, will be at x equals to 3, correct? So on a graph paper, if you sketch all these points, you'll get something as shown here, right? So you can label all the points and then that'll be good for you. So that is the function x squared minus 6x plus 9. Perfect. So that is how you're going to sketch it. Question number 5. Solving minus 0.5x squared minus 3x minus 1 by completing squares. So we are given minus 0.5x squared minus 3x minus 1. So we can write this as factor out minus 0.5. So we get x squared minus. When you divide 3 by minus 0.5, this sign changes to plus. This is like half, right? Remember, 0.5 is half. So when you divide by half, 3 gets multiplied by 2. We get 6x here. Keep this number away, right? Now the next step here is we have to add and subtract half of 6 square, right? 6x. So half of this will be 3. So we'll add and subtract 3 square. Now these three terms form a perfect square. X plus 3 whole square minus 3 square is minus 9 minus 1. Now we can open the bracket. Minus 0.5 x plus 3 whole square. Minus and minus becomes positive. Half of 9 is 4.5. and we have minus 1. So we get minus 0.5 x plus 3 whole square, and that is plus 3.5. Is that clear to you, right? So we have done this particular solution. But this question was probably solve this by completing the squares. We need to find the vertex. So we have to find the vertex in this case. And our answer is vertex is at minus 3. The value is 3.5. Is that clear to you? So that becomes the vertex of the given quadratic function. Now again, this question was also solve this by partial factoring to find vertex. Correct? So I missed that part in typing. So now we'll use different method, which is partial factoring, to find the vertex. So we have the function which is 6x squared plus 24x minus 3. Partial factoring means you factor these two, right? So that is partial factoring. So amongst these two, we have 6 and x as common. So we get x plus 6 goes 4 times minus 3, right? So that is how we could partially factor it. That really tells you that at x equals to 0, let's say this is a function f of x, right? So that really tells you that f of 0 is equal to what? Is equals to minus 3, and f of minus 4 is also equal to minus 3, right? So this parabola which opens upwards has the value of minus 3, let's say this value, at 2 points. These 2 points are at minus 4, we have a value minus 3, and also at 0 we have a value of minus 3. That really means that the axis will be midway, right? So from symmetry, axis will be at x equals 2. You can add these two values of x, right, which is minus 4 plus 0 divided by 2, which is at minus 2. So the equation of this axis of symmetry is x equals to minus 2. Now the point, which is the vertex, lies on the axis of symmetry, right? So the minimum value at the vertex will be what? So we can now write the value at x equals to minus 2. So substituting minus 2 here, I get 6 times minus 2 plus 4 minus 3, correct? So you can calculate this value, which is minus 12, and that is 2 minus 3, and this gives you the value minus 24 minus 3, which is equals to minus 27, correct? So the vertex in this particular case will be at minus 27. So we get our answer that the vertex is at minus 2 minus 27. Is that clear to you? Correct? So the value of the minimum value, because it opens upwards, will be at x equals to minus 2. And when you substitute minus 2 into your equation, 6 minus 2 is minus 12, minus 2 plus 4 is 2. So 2 times minus 12 is minus 24, take away 3 gives you minus 27. Is that clear? Now partial factoring is a very effective method of finding the axis of symmetry and then the vertex. Question number 7. Determine equation of parabola with roots minus 2 and 6 passing through the given point 1, 4. So the concept here is that the function f of x will be equals to a times x minus x1 times x minus x2, where x1 and x2 are the roots. Correct? So we can write a times x. The roots are at minus 2. So if I write minus 2, it becomes plus 2. And at 6, which is x minus 6. Correct? So that is our function. Now we are also given here that we have a point P, which is 1 and 4. So 4 is the y value, x value is 1. So we can write this as 4 equals to a times 1 plus 2 times 1 minus 5. This helps to find the value of a, right? 3 times, and this is minus 4. So we can write the value of a as 4 divided by 3 times minus 4, right? So we get the value of a as minus 1 over 3, right? Therefore, we can now write the equation of parabola, which is our function, quadratic function, as minus 1 over 3 x plus 2 times x minus 6, correct? So that becomes the solution. Is that clear? Now let's take the next question, which is question number 8. You can always pause the video. This is very similar to what we just did. Find the solution and then look into my suggestions. Question number 8. Find equation of parabola with roots at, so we have two roots. x1 is at minus 1, x2 is at minus 7, and we have y-intercept. So y-intercept is at minus 9. That means the point is x value is 0, right? That is how you get your point. So the function f of x can now be written as a times x minus x1 times x minus x2. Now we are given the two roots, so we can write that. So we have x plus 1 times x plus 7, substituting minus 1 and minus 7 for x1 and x2, right? Now, to find the value of a, we'll use the y-intercept, 0 minus 9. So we have minus 9 equals to a times 1, substituting 0 here, right? So we get minus 9 over 7 as the value of a, and therefore the function for us is minus 9 over 7 x plus 1 times x plus 7. Now at times you may be required to write the equation standard form. So for you, question number 2b will be write the solution in standard form. So you need to expand and then write it in standard form. Okay, so that is an extension. Question number 9. Find equation of parabola which passes through this point and the roots are 3 plus minus square root 7. Now this becomes slightly difficult. So in this case, we'll still use the same equation, a times y f of x equals to a times x minus. Now the root is 3 plus square root 7. So let me write within brackets 3 plus square root 7, two brackets close, and then x minus 3 minus square root 7, right? So these are the two roots. Perfect. So let us open the bracket. So we have here x minus 3 minus square root 7 times x minus 3 plus square root 7. So signs will change, right? Now think about x minus 3 as one part, and then we have plus minus 7, right? So we'll use the strategy that if I have a plus b times a minus b, if you multiply that, you get a square minus b square, correct? So here, in our case, a is equal to x minus 3 and b is equals to square root of 7, right? So when you square root of 7, so if you do b square, you get 7, clear? So that is what we are going to use here. So when you open, you get a times, let me write like this, x minus 3 whole square minus 7. Is that clear to you, right? So a square minus b square, correct? Now we are also given that it goes through the point 2 minus 18, right? So we have a point through which it goes, which is 2 minus 18. So I'll substitute this point at this stage to find the value of a, right? So let's find 8. So we have minus 18 equals to a times, I'm substituting 2 here, right? So 2 minus 3 whole square minus 7, right? So we get minus 18 equals to a times. Now 2 minus 3 is minus 1, right? So we get here minus 1 square minus 7. So we get minus 18 equals to minus 1 is plus 1 square of that, right? So we get 6 minus 6a as 1 minus 7 is minus 6, right? So from here we get minus 18 divided by minus 6, the value of a, which is equals to 3. Clear? So we get the value of a as 3, and now we can write down our solution. So the equation of parabola f of x is basically equal to, so we got the value of a now, we'll substitute here, is 3 times all this, right? So 3 times within bracket we have x minus 3 whole square minus 7, right? So we can open the bracket and write this as 3 times x minus 3 whole square minus 21, right? Is that clear to you, right? So what we did was, let's go through it once again. The two roots were given to us, so we use x minus x1 times x minus x2, rearranged. Then product was a square minus b square. Then instead of simplifying this, it was better to substitute the point, calculate the value of a. So we got the value of a and we got this in the vertex form. So that is our parabola in the vertex form. Is that clear to you? Correct? So that's how we're going to find the solution. Now again, as we did earlier, question 9b, write in standard form. Is that clear, right? So let this be an extension for the same question. Question number 10. Determine the number of intersections of the following linear quadratic system. Now we are only interested in finding number of intersections, right? Not solutions. So in this case, what are we going to do? So we are going to analyze b square minus 4ac, right? So in each situation, we are going to analyze b square minus 4ac, which is the discriminant, in the equation ax square plus bx plus c, right? So if b square minus 4ac is equal to 0, that means what? If b square minus 4ac is greater than 0, it means what? And if b square minus 4ac is less than 0, it means what? Well, if it is equal to 0, then we have one solution. If it is greater than 0, we have two solutions. And if it is less than 1, we have no, and what are these? No real solutions. Is that clear, right? So normally, a quadratic function will always have two solutions. They could be imaginary or real, right? Or they could be same two values. So we have exactly same value, both are at the same point when b square minus 4ac is 0. But if it is greater than 0, that means positive, then 2. Likewise. Do you understand? So that is how we have to understand the situation. Correct? So I will actually do some of them for you. For example, a, right? Let's begin with a. So a is x square minus 2x plus 1 and gx is x minus 2. So what first step we'll do is, we have x square minus 2x plus 1 equals to x minus 2. So intersection means at one point they have a common point. That will be the point of intersection. So that means equal to, right? So let's rearrange. So you could write this as x square minus 2x plus 1 minus x plus 2 equals to 0. Combining the like terms, we get x square minus 3x, 1 plus 2 is plus 3, equals to 0, right? So we get to the equation in standard form, which is this. Is that clear? Now we know that b is minus 3. So let's test for b square minus 4ac now. So now we'll test for b square minus 4ac, right? So in this case, b square is minus 3 square minus 4 times a is 1, c is 3 for you, right? So which is 9 minus 4 times 3 is 12. So 9 minus 12 is minus 3. Now since this is less than 0, right, so that is this condition. So for this particular case, we have no real solution. Is that clear to you? Similarly, you should do part B. So part B is we have 2x squared minus 3x plus 4 equals to 3x plus 4, right? Bring them together. 2x squared minus 3x plus 4 minus 3x minus 4 equals to 0. So that gives you 2x squared minus 6x, and 4 minus 4 is 0, right? So we get this situation. Now this one, if you test this out, what do you get? B square is minus 6, right? So we have minus 6 squared minus 4 times a is 2. However, c is 0, right? So you get 36, which is greater than 0. So we have two real solutions. Perfect. And now the last one is minus 16. So let's complete that. In the limited space, I bring it on the left side. So we get x squared minus 6x. So when you bring it here, it becomes plus 16, right? So when you add 16 to this and take away 7, you get plus 9 equals to 0, right? So in this particular case, b squared is 36 minus 4 times 9, so which is 0. So in this case, we get exactly one real solution. Is that clear? So that is how we are going to find how many solutions do we have, right? Now here's an extension. Let's say question 10b, find solutions to linear quadratic system. Correct? So let this be an extension. So I hope that will give you good practice. Let's move on to question number 11. Question number 11 is, given linear quadratic system, f of x equals to kx squared plus 4x minus 3, g of x equals to 2x minus 7. Determine the value of k for one solution, no solution, two solutions, right? So it's very similar to what we just did. So solution means f of x should be equal to g of x, correct? So we have here kx squared plus 4x minus 3 equals to 2x minus 7. Bring them together. Kx squared plus 4x minus 3 minus 2x plus 7 equals to 0. Kx squared, 4x minus 2x is 2x, minus 3 plus 7 is plus 4 equals to 0, right? So we'll analyze b squared minus 4ac to find number of solutions. Is that clear? Now b in this case is 2, so we have 2 squared minus 4 times a is k and c is 4. So we have 4 minus 16k, right? So we have this situation. So first, we'll work for the condition A, which is one solution, right? So one solution. One solution means b squared minus 4ac equals to 0. So to find that, we'll equate 4 minus 16k to 0, and that gives you that 4 equals to 16k, and that implies k equals to 4 over 16, which is 1 over 4. Clear? So for a value of 1 over 4, we have one solution. Now B. We want now how many solutions? No solution, right? So no solution means what? No solutions means b square minus 4ac is negative, right? So that we know when it is 0. So that really means that 4 minus 16k is less than 0, or that gives you that 4 is less than 16k, and that gives you that k is greater than 1 over 4. Perfect. K is greater than 1 over 4. And part C for this is two solutions, right? Two solutions means b square minus 4ac should be greater than 0. Again, we are going to solve the same equation. So we get 4 minus 16k should be greater than 0. That means 4 is greater than 16k, and that means 1 over 4 is greater than k, or k is less than 1 over 4. Is that clear to you, right? So for each we got the solutions. Let me just summarize the answers right there. So for this, k is equals to 1 over 4. For no solution, we found that k is greater than 1 over 4. And for two solutions, we have that k is less than 1 over 4. Is that clear to you, right? So that is how we are going to get the solutions. Now, it seems to be very clear since we have minus 3 as our y-intercept, correct? So if k is less than minus 4, then we could get a situation where if both signs are same, right? So what we get here is that it may open downwards, right? And it may not intercept, right? So that is how we have different situations here. Does make sense to you, right? So if you sketch it with different values, we may get a parabola, which could be something like this. Since this is minus 3, if it is opening upwards, then we have a parabola which is kind of like this, maybe, right? Maybe like this. Or if it is, those were the situations which will give you a different number of solutions, right? And something like this can give you one solution. Is that clear to you? Correct? Because this is your y-intercept, right? So we have different situations where you may get one solutions or no solutions, and something like this may give you no solution, right? So that gives you a fairly good idea of what value of k could be for different kinds of situations, right? So with that, we end this test paper. I hope you learned different strategies to solve such questions. Now, these are very important questions from any test point of view based on quadratic functions, right? So once again, here's your list. And we have solved all of them one by one. We do have many videos on each topic to practice. So I'd like you to go through the list of my videos on these topics and gain more confidence. I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.